All right, if you're deep in your physiology studies, there is one system you absolutely positively have to know for your exams, the RAAS pathway. It pops up everywhere. So today, we're going to break it all down step by step so you've got it locked in for exam day.
So let's just start with a really basic question. When it comes to controlling your blood pressure, what's the body's #1 most powerful system? Well, you probably guessed it, it's the renin-angiotensin-aldosterone system, or RAAS. And understanding this isn't just about memorizing facts, it's about really getting how your body handles one of its most critical jobs.
You know, every process has a trigger, right? An inciting incident. And for the RAAS pathway, it all kicks off with one single thing, a drop in your blood pressure. That's it. That's the one and only signal that gets this entire powerful cascade started. And what's so cool is just how fast the body jumps into action. It sees that drop in blood pressure as a major threat, and boom, the first system to sound the alarm is your sympathetic nervous system, your fight-or-flight response. It immediately knows something's wrong and gets ready to act.
Okay, and this is where you see that first crucial handoff. The sympathetic system unleashes the neurotransmitter norepinephrine. And for your exams, you absolutely have to know this next part, that norepinephrine targets very specific beta-1 receptors that are located right on your kidneys. This is basically a direct order to the kidney saying, hey, we've got a problem, release the first messenger. And in response, the kidney does just that, squirting a very important protein into your bloodstream.
And that protein is renin. So here's the key takeaway. Renin comes from the renal tissue, right? Renal just means kidney. It's a great way to remember it. And its one and only job, its entire purpose, is to get the ball rolling on this pathway. Seriously, remember that. Renin from the renal tissue. That is a classic exam question right there. All right, let's follow the chain. We've got renin in the blood, but it can't fix low blood pressure all by itself. It needs to start a chain reaction, a sort of conversion cascade that travels from one organ to the next. And tracing this journey is really the secret to mastering this whole thing. So get this, while all this action is kicking off, your liver has been working in the background the whole time, just pumping out this precursor protein called angiotensinogen. Think of it as just sitting there, waiting for its moment. Now renin, which is now floating around in your blood, finds this angiotensinogen, and boom, it makes the first conversion. The result? A new molecule called angiotensin 1.
But angiotensin I? Well, it's just a middleman. It's not the final hero molecule just yet. It isn't nearly powerful enough to fix the problem on its own. So it keeps traveling through the bloodstream, and its next stop is a big one, the lungs.
And what's waiting for it in the lungs? This is another one of those names you have to burn into your brain. ACE. It stands for angiotensin converting enzyme, which helpfully tells you exactly what it does. And its location? The lungs? Oh yeah, that's another one of those super common test questions.
So as angiotensin I is passing through the tiny blood vessels in the lungs, ACE does its thing. It performs the second and final conversion. It transforms the kind of weak angiotensin I into the super powerful, fully active molecule angiotensin II. This is the guy we've been waiting for. This is the one that's going to save the day.
Okay, so our hero molecule, angiotensin II, is finally on the scene and circulating in the blood. So what's its plan? It doesn't just do one thing. It has this awesome two-part strategy to get that blood pressure back up, and yep, you guessed it, you need to know both of them for exam day. First up, angiotensin II is a monster vasoconstrictor. I mean, it squeezes your blood vessels hard. Just imagine pinching a garden hose. The pressure shoots right up, right? Same idea. But it's not done. Second, it takes a trip over to the adrenal glands, specifically the adrenal cortex, to tell them to release another hormone. And here it is, the final piece of the puzzle, aldosterone. That's the A in RAAS. And hey, if you want some bonus points on your exam, remember it comes from a specific zone called the zona glomerulosa. Aldosterone's job? It tells the kidneys, hey, hold on to more salt. And you know the rule, wherever salt goes, water follows. More water means more blood volume, and more volume means higher pressure. And that's it. That's the 1-2 punch that solves the problem.
Whew, okay, that's the whole pathway, from the initial trigger all the way to the final fix. So let's put it all together. Seriously, if you're going to take a screenshot of anything from this whole explainer for your study notes, make it this next slide. This is your study guide right here.
Okay, so let's just trace the flow one last time. It all starts with angiotensinogen, which comes from the liver, right? Then renin from the kidney jumps in and turns it into angiotensin 1. Next stop, the lungs, where ACE converts that into the powerhouse angiotensin 2. And what does angiotensin 2 do? Two things.
vasoconstriction, and it tells the adrenal cortex to release our final player, aldosterone. You see the journey? Liver to kidney to lungs to the adrenals. If you can remember the molecule, where it comes from, and what it does, you're going to nail any question they throw at you.
And let's end with this kind of a food for thought question. We just walked through the body's master plan for raising blood pressure, right? So, think about it from a clinical side. If you have a patient whose blood pressure is too high, how would you lower it? This pathway is basically a treasure map of drug targets. Are you going to block an enzyme like ACE? Or maybe stop angiotensin II from doing its job? See, that's how you connect physiology to pharmacology. And that is when you really start to understand it all.